All right. So assuming that you are comfortable using the compound angle formula that's going back and forth, okay? And knowing that if you go back and forth, sometimes you will have to use Castro. My next example is using Castro ahead of time so that you can use angles that are smaller than 90 degrees or pi over 2. Consider this. Okay? If you have an angle larger than, let's say, if given an angle that goes beyond what you can make with the special triangles, in other words, the largest angle we can make is 105 degrees, aka, what is it, 7 pi over 12? If there's an angle that's larger than 7 pi over 12, you might want to make it smaller so that this is a lot easier. For example, 23 pi over 12 is almost 24 pi over 12. Remember, just from fractions, bless you. 24 pi over 12 is 2 pi, right? So this is just under a full rotation. If you know this to be pi over 12, using CAST rule, C-A-S-T, you can use your acute related angle and rewrite this as sine of the acute related. But because quadrant 4 corresponds to cosine, the overall value becomes a negative. That's it. Now that you have pi over 12, aka 15 degrees, we use our compound angle formulas. Pi over 12, that would be, let's say, 45 minus 30, or 60 minus 45. Let's do 45 minus 30. Pi over 4 minus pi over 6. And there's your question. We have all the angles that are smaller than 90 degrees, and we just plug it in using special triangles. Question?
Why do you put a negative in front of the bracket? Or why does it have a negative?
Oh, CAST rule. Remember, if I have sine 345 degrees, I can rewrite this as negative sine 15 degrees using CAST rule, right? So that's what I did. And now that I have 15 degrees, that is 45 minus 30. I can use compound angle formula. So again, you have to do this. Once again, please, no, you don't have to. Do whatever makes your life easier. I'm just showing you different tools in your toolbox. And I hope you feel more and more comfortable as time goes on of using one or the other anywhere you want. So sine, angle minus an angle, meaning sine, cos, cosine. This is sine, cos, and because that's a negative, that's subtraction, I will subtract cos with sine. Sine, cos, cosine, subtraction, because there's subtraction. Right. Now let's do it. Sine pi over 4, root 2 over 2. Cosine pi over 6, root 3 over 2. Minus cosine pi over 4 is root 2 over 2. Sine pi over 6, 1 over 2. Root 6 over 4 minus root 2 over 4. My final answer is distributive property, and simplifying, I'll write it as one fraction. Negative root 6 plus root 2 all over 4. Of course, you can leave it as separate fractions as well. You can write negative root 6 over 4 plus root 2 over 4. They're both fine. Okay. So that's essentially it. As practice, I'm not going to go through it, but we'll try CAST rule just as another exercise. Cosine 17 pi over 12. It's really important that you can identify which quadrant that is. 17 pi over 12. Remember, if the denominator is a 12, well, 1 pi, in this case, would be 12 pi over 12, which means 3/4 would be 18 pi over 12. 12 pi, 18 pi, 17 is going to be between the two. So I have this. If that is 17 pi, what would the acute related angle be? With a little bit of effort, I'm sure you can do some fraction subtraction. You will see that it is going to be something plus or minus cosine 5 pi over 12. CAST. Only when we use the acute related angle for tangent does it remain positive. Therefore, this cosine must be a negative value. The rest, I think you can try on your own. Yes?
How did you get that 5 pi over 12?
Okay.
Is it 1 pi to the...
Ah, you are talking about this angle, correct?
Yeah.
That would be the correlated angle for the cofunction. What does that mean? If you wanted to use this angle pi over 12, that means cosine would be converted to its cofunction.
That's the word.
Yeah. Cosine of, 17 pi e. Yes. So negative cosine 5 pi over 12 should give you the same answer as negative sine pi over 12.
So how did you get the 5 pi over 12?
Well, I know that this portion right here, all the way to that portion right there is 18, yes?
Oh, yeah.
Here to here would be 17. So 12, how much more did I add? All right, and the rest, I'll set this up for you. Cosine, that will be 75 degrees, okay? But I hope that you'll be able to figure that out on your own. Pi over 4 plus pi over 6. See if you can solve that. Okay. Would you like some time to try it now, or should we go on to, yeah, okay. I'll give you exactly 4 minutes and I'll pause the video. All right, coming back to this, because it is a negative, I'm gonna stick that there first and I'll solve inside the bracket. Cosine is cos cos, sine sine. And because that's an addition, you should have a subtraction of the two terms. Plugging in, we've got root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1 over 2. This is well, basically the same thing as above, wasn't it? Sort of. Huh. Just making sure I don't make any mistakes.
It is the exact same.
It is the exact same, right? I'm not going crazy.
Yeah, it is. Quite different.
Yes, it is the exact same. So we've got root negative 6 over 4 plus root 2 over 4, or you could write that as a single fraction. And there it is. Question?
I still haven't fully wrapped my head around the whole negative thing. At the beginning of the question, where you put negative number close. I understand sort of what you said, but to me, like, when you have the original equation, would that also be negative because it's in the 10 quadrant or something?
The original question. Well, once again, I'll just reiterate cast rule, and hopefully you'll be able to arrive at your conclusion, if that's the question that you're asking.
This is like a one-on-one question.
So as in, why is this there?
Yeah.
That we can do. Remember, CAST is going to be very important. If I have an angle of 225 degrees, it is creating, this point right here, I can argue, is creating a triangle upside down. It has a negative x value and a negative y value. Would you agree? Okay. Now, what's interesting is, because I know this is 180 degrees up to here, because that's 180 degrees, I know this angle close to the origin is 45 degrees. Does that make sense? Okay. So, oh, I have a triangle that has 45 degrees as one corner. Well, it's basically the same as this, imaginary wise. It's the same triangle because my radius here is 1 and my radius here is 1. The only difference is my x value is positive and my y value is positive. So I can use the information from quadrant 1 because all the numbers are positive and I'm happy, and then apply it to quadrant 3 depending on which values are negative. So if I have cosine of 225, which is, if you remember, the x over r, right? I could pretend to get the same answer from cosine 45, x over r, but because the x value is negative, this one has to be negative of whatever I get from quadrant 1. Long story short, if you have a very large angle, pretend it is of an angle under 90 degrees and do SOHCAHTOA. When you do so, you'll get some kind of ratio. You just have to remember, if you used an x, it's a negative. If you used a y, it's a negative. And
So basically, it's saying like the original question, whatever the answer will be negative because of the negative x over r.
that's right.
So you're solving it with maybe throwing in.
That's right. If you plug this into the calculator, you will get a negative number. If you plug this into the calculator, you get a positive number. So you have to compensate by sticking a negative. That's Castro, basically. Okay? Let me see if I could clean this up a little bit. Okay. I don't know if I would call this a true T question because you should have the awareness to try it, but let's pretend we're seeing something like this for the first time. It's been a bit of a struggle and you're gonna get stumped, okay? When given specific ratios instead of angles, in other words, ratios like the answer instead of the actual angle, illustrate what you're given visually and it might help you answer the question. For example, leave some space here because I'm gonna do special triangles, okay? Sine A is 5 over 29, or root 29. Cos B is negative 5 over 13. A is in quadrant 2. B is in quadrant 3. That's what the question gives you. Okay? Just for now, keep that in mind. Leaving a little bit of space. A. What is sine A plus B? Okay. Using compound angle formulas, that is going to be sine cos, cosine. Well, what do we know about sine A? It's given to you. Sine A is, what was it? 5 over root 29. Do we know cos B? Yeah. Cos B is given as negative 5 over 13. What's cos A? Do we have cos A? Is it given? No. Do we have sine A? It's a given. Oh, sorry. Is it sine B? Is it given? No. But we can find it. How do we find it? What is the connection between this and finding cos? If you remember what I said in the beginning of class, you might remember. Yep. Yeah. Why? Why would that help?
Since the capital root 29 is going to be the diagonal, then because it's sine, you know, the phi is the opposite, so then you can solve it.
Yes. Please remember, if you have a ratio, you have all three sides of the triangle. If you have a ratio, you know that sine of an angle means the y is over r. If you have cosine of an angle, you automatically know that it's x over r. So, if this is sine A in quadrant 2, what is y? Y is positive 5. Is that? What is that told from? Is it? That sounds so familiar. Like from a video game. I could be wrong. Anyways, and R would be that. I have my Y, I have my R, you can find this. Same thing, angle B. The question already said it was in quadrant 3. Cosine of B is x over r. My x is negative 5. My r is 13. I can solve for y. So let's go solve the happy faces. We've got c squared equals a squared plus b squared. So root 29 squared is just 29. That is equal to 5 squared plus the x value squared. That is 25 plus x squared. That means subtract 25 on both sides. 4 equals x squared. So x is plus or minus 2. But one of them is obviously rejected. It can't be both. Being in quadrant 2, the x value would be negative. Right on. So that's a negative. That's going to help you. So now that we have the x value, we can figure out cosine. Let's do it again here. C squared equals a squared plus b squared. So we have 13 squared is equal to negative 5 squared plus y squared. That's 169 equals 25 plus y squared. Subtract 25 from both sides. We've got 144, which means y is plus or minus 12. But since it's in quadrant 3, it's got to be negative. So in quadrant 2, therefore, x equals negative 2. In quadrant 3, therefore, y equals negative 12. Here we go. Since I now have x for the A angle, y for the B angle, I can say that this is 5 over root 29, negative 5 over 13, plus cosine A, which is x over r, that is negative 2 over r. And sine of B is y over r, negative 12 over r. And the rest is just solving. I am going to rationalize the denominator, so stay tuned. We've got negative 25 over 13 root 29 plus 24 over 13 root 29, which means I have this as my answer, but if I rationalize it, I have negative root 29 over 13 times 29. I'm going to cheat. 377. B and C, I will write out the answers for you to check, but I'd like you to try it as well. What is the goal? Why did I ask you to try this example? It's to remind you that if I give you one ratio, I actually gave you the entire triangle. You have to be able to remember that. So if that helps you by drawing out the triangle and figuring out whatever, then great. If you don't need to do that, then don't. It's all under the same system. I hope that you will remember. This is one of the many things you can do. And that's it. I'm gonna answer B, answer C on this page, and I think it's already uploaded actually, but you can check here with me. That's the end of today. Being able to use compound angle formulas and some other sort of twists to it where you have to use previous knowledge. Any questions about what we just did? I imagine all you need now is just practice because you understand what we're doing. It's just a matter of making sure you're adept at it. I already gave you the assignment for the homework from the textbook, just trying as many as possible. For the rest of class, I would ask that you at least try letter B because it is a cosine. Tangent, you don't have to do, but you know, because it's not going to be on the test, but I'm still going to do it for you anyways. Once you have at least done letter B, please use the rest of time to study whatever the test might be next period. Yes. A pointer about the assignment. It is going to be about trig identities. You get it on Monday, and we review how trig identities are done in class. We will continue review of trig identities on Tuesday, and as a class, everyone hands in their own on Wednesday. And you can take it home, you can make a study group, you can do whatever you want. I encourage you to have math discussions if need be. Okay. Questions? All right, I'm gonna solve this, and then I'll pause the video, I'll stop the video, and then you can use this time as you see fit. B. We've got cosine A minus B, which is cos plus sine. That is cos A, negative 2 over root 29. Cos B, negative 5 over 13 plus sine A, 5 over root 29. Sine B, negative 12 over 13. That is 10 minus 60. There.
I'm not gonna be here on Monday because I have first meeting game in school, so is the assignment gonna be posted online?
I can do that for you.
Okay.
Mm.
And then it's just trig identities?
Yeah. Am I doing video for you too? It's not a hassle per se. I just need to know.
for the interruption, Mr. Bessie. Mr. Bessie, your presence is requested in room 102. Thank you.
Tan B is -12 over -5.
We have to know how to do and on the test. No, right?
No, it will not be given to you. A is y over x. What is my y for A? 5. And what is my x? -2. Okay. And B. Minus plus. Oh, negative. Times 2, 24 times 5, 24, 25, 49. That's it. Okay, I'll leave this here for you before, and I'll I guess turn off this video.